Hi, a warm welcome to the PhD forum of ISC High Performance 2020 Digital. My name is Laura and I'd like to give you a short overview of my PhD project in which I'm aiming at fine-grained task parallelism on GPUs. The main motivation for my work is that task parallelism is actually pretty omnipresent these days. So its application domains reach from data mining to machine learning right up to molecular dynamics. The main goal of my project is to exploit the parallelization potential of applications that exhibit fine-grained task parallelism. So applications that exhibit many tiny dependent tasks and like to run on GPUs. To reach this goal, I am adapting and extending the C++ tasking library Eventify to GPUs with CUDA. However, the concept would also work with OpenCL or HIP or SYCL. So the original use case of Eventify, which it was developed hand in hand with, was a Fast Multipole Method for molecular dynamics. So regarding GPU Eventify, I'm just sticking to this use case. Yeah, let's come to a short introduction of CPU Eventify. Eventify is a task parallel programming library written in C++, which supports applications with many tiny dependent tasks, but with a limited set of task types. So for such applications, Eventify allows the algorithm developer to provide a very concise and short description of the data flow graph instead of these lengthy and loop-based task graph descriptions that usually have to be evaluated at runtime. Furthermore, Eventify allows the execution along the critical path as well as static and dynamic load balancing. Yeah, let's see how to transfer these features and the components of CPU Eventify to GPUs. After all, we're aiming at a uniform approach for CPUs and GPUs, and so reusing as much as possible and emulating these concepts on GPUs is reasonable. So therefore, the fundamental idea is to emulate the task lifecycle, respectively the tasking workflow itself of CPU Eventify on GPUs with persistent threads. So in our approach, this means that there is one persistent thread kernel per task type, not per task, but per task type. And the vital point here is that the workflow of the task execution is the same for each task type. So meaning we have our persistent thread here, which is basically the while loop, with its content, which is the task execution workflow itself, and the task execution on this single line. So each thread in each thread block executes a task of the same task type, but on a different task object. And for each task type, there's one such persistent thread kernel. Yeah, besides this basic version of Eventify on GPUs, we already implemented some optimizations, especially regarding the queuing infrastructure and the memory usage. For an in-depth description of these optimizations, please consider our talk at GTC Digital 2020. Nevertheless, I insist on providing a spoiler to this talk. So the most lucrative optimization was actually splitting the global shared queue, which all threads had access to, into multiple smaller queues. And with these multiple queues, we were able to reduce contention, and finally, the application was over 200 times faster. Yeah, next steps are the extension of our performance analysis, the implementation of a full-fledged FMM, the use of CUDA streams to overlap tasks, as well as a uniform API for algorithm developers. Yeah, please feel free to contact us with questions or comments, and thanks for watching.